Good morning. We're here in Milan, and I'm introducing David Werring, who's the chief investigator of a really interesting study on microbleeds. David, you and your team have put together this fantastic analysis of over 20,000 patients with ischemic stroke or TIA, looking at from 38 cohorts, looking at what microbleeds on a brain mean. So can you just summarize for us what we need to know as clinicians from this study?
Thank you, Peter. So this study, as you say, looks at microbleeds, and it's addressing what I think is one of the central issues in stroke medicine. So we have someone with an ischemic event, ischemic stroke or TIA. One of our conventional treatments is antithrombotic drugs, which we know are effective for many years, thanks to some of your early work, of course. And one of the concerns for clinicians is the risk of bleeding, particularly intracranial bleeding. And because microbleeds reflect small areas of bleeding in the brain, at least some of them do, there's been concern from clinicians if they see microbleeds that this could herald a high risk of intracranial hemorrhage.
Do you think it's put a lot of clinicians off giving effective antithrombotic treatment?
I'm sure it has, particularly anticoagulants.
So just tell us a bit more then about what sort of findings you achieved by putting all of that data together.
So what we found was microbleeds at baseline, so people who've had an ischemic stroke or TIA, were associated with an increased hazard of both ischemic stroke and intracranial hemorrhage. The risk of intracranial hemorrhage went up more steeply than that of ischemic stroke. This is a relative risk, adjusted hazard ratio, but if we look at the absolute risk, even with large numbers of microbleeds, or 20 or more microbleeds, the absolute risk of ischemic stroke was still very substantially higher than that of intracranial hemorrhage.
Okay, so if we took, say, 1,000 patients with ischemic stroke or TIA, gave them antithrombotic treatment for a few years, what would the absolute number difference be? So how many hemorrhagic strokes, how many ischemic strokes?
So per 1,000 patient years, it would depend on the number of microbleeds, and I'm struggling to think of the exact numbers. I think for 20 microbleeds, it will be something like 70 ischemic strokes per 1,000 patient years and about 30 intracranial hemorrhages, so more than...
So very clearly, even if you've got a lot of microbleeds, you're still more likely to have an ischemic stroke than a hemorrhagic stroke.
Yeah, and substantially more likely.
So do you think this meta-analysis will persuade clinicians that it's okay to give antithrombotic treatment even to people with a high load of microbleeds?
I think it will. It provides reassurance. The limitation, of course, is that it's not randomized data, so we cannot show a true interaction between antithrombotic drugs and microbleeds.
Do you think we'll see any randomized trials taking a population of people with microbleeds and randomizing them to treatment or not? Or do you think clinicians will just say, oh, it's okay, we can go ahead? What do you think?
I would love to know the views of the community on that. And if a randomized trial was supported by the community, I'd love to be involved in trying to do that. But I suspect, with all the proven evidence for antithrombotic drugs and now our observational data, clinicians will probably think that this issue is at least partly resolved.
Well, one might imagine that there might be people, say, with a minor stroke or TIA with no evidence of anything like AF. They might be persuaded to use an antiplatelet drug. But if you've got patients with AF and a lot of microbleeds, do you think there's a place there for a randomized trial of different anticoagulant or antithrombotic regimes there?
I think there's potential for people with very large numbers of microbleeds. One could consider randomization to antithrombotic drugs versus non-pharmacologic therapies like left atrial occlusion or something like that.
So very, very interesting data, reassuring for clinicians, but opening the door to some interesting trials as we go forward.
Potentially.
David, thank you very much. That's fantastic.
Thank you, Peter.